to know that mesomeric effects, so if we draw the resonance structures, overrule the inductive effect in most of the cases. So not always, but in this case it will overrule that. So if you draw this one, we still have the attack on the primary carbon, and the negative charge will be formed at the secondary carbon. What will yield exactly the same as in the cationic and free radical polymerization. So no inductive effect, what is promoting destabilization, but we do have a stabilization effect caused by the ring. So we can also draw, and I draw one of the three stabilization processes. This negative charge can go here, where we form here a double bond. So I do it now a little bit faster. So negative charge here, and those double bonds are maintained. And of course here we can also form here the double bond, and we can form at this position the double bond, the negative charge. Yes? So I don't draw this one, but those are two examples, and we have two more examples. So what is the conclusion? For styrene, for example, we can choose between radical polymerization, cationic, or anionic polymerization. There might be some differences, but that is we have to study that in practical sessions. But now we just base it on theoretical things. So we can choose between three mechanisms. Once again, it's very important not to remember what mechanism takes place for what monomer, but you have to see for yourself how the resonance structures will look, and how the inductive effect takes place for the mechanism, and then you have to choose what is the most stable position. And once again, the mesomeric effect, so the effect of the ring, will overrule the inductive effect in this case. So a last example. For example, when we have an acrylate structure, so in this case methyl methacrylate, what do we choose then? So if we have to analyze the monomer, so this is a CH3 group, say H3, here we have a CH2 group, CH2, double bound, so this is the reactive part of the monomer. What do we know? So here we have a tertiary carbon, here we have a primary, etc. So from an inductive way of thinking, inductive effect, we should think that the attack has to take place at the primary carbon, so that the radical or the cationic species, cationic charge of the cationic polymerization, so the positive charge is positioned at the tertiary position on the tertiary carbon. So from this way of thinking, we think of a radical polymerization or a cationic polymerization. But this is an inductive way of thinking. So now we have to know if there is also a mesomeric effect. And yes, we do have one. If we can put here a charge or a radical, can it be stabilized by the oxygen, the carbonyl group here? Yes. So if we position here a negative charge, we can draw some resonance structures between the negative charge here on the carbon here and the oxygen here. So we have a mesomeric effect, what will promote the anionic polymerization. So what do we choose? We can choose for the we will choose for the anionic polymerization because the mesomeric effect will overrule the inductive effect. So our first guess will be an initiator with a negative charge, so an anionic polymerization. We have a look at this, so how it will look like. And on the side, you can also see that if the negative charge attacks here, we get here at the end a negative charge is a primary carbon, so that is very good for the negative charge. But if we position it here, we have the mesomeric, the resonance stabilization, and that will overrule. So it will look like this. CH3, I forgot it here, negative charge here, then we have the oxygen, CH3. So draw the Lewis structures, so we can see if we can have some resonance effects, and yes, this carbonyl group can facilitate a negative charge, so we can draw the resonance structure like this. Double bound, oxygen with a negative charge, etc. And that's a quite good position. From this point of view, we can also facilitate a free radical polymerization, because we can stabilize it quite well here on the tertiary carbon. However, the positive charge, so the cationic polymerization, is not a very good idea for this monomer, because it's quite well stabilized by the tertiary carbon here for the inductive effect, but the mesomeric effect will cancel this out, because a mesomeric effect does not place at all. So how do you know this? This oxygen is partially charged by partially negative charged, and this carbon is partially positive charged. So if you position here positive charge for the cationic polymerization, you see here that is not quite stabilized at all. So if you position here radical, what is an electron, it can be stabilized by the carbon because of the inductive effect. So now it gets a mess, but I made my point, hopefully. So what is the conclusion for this monomer? Is that we can choose for anionic polymerization, we can choose for a free radical polymerization, but we don't choose for a cationic polymerization.